Hello, we are the GEENgineers. I'm Noah Wellickson, an engineering physics major.
I'm Chris Stone, and I'm majoring in applied mathematics.
I'm Max Richards, and I'm majoring in mechanical engineering.
And I'm Michael Jones, and I'm also majoring in mechanical engineering.
Hey guys, we are Team Camp. I am Branson, and I'm majoring in mechanical engineering.
I'm Grace Lee, and I'm majoring in Engineering Plus.
I'm Leland Yoder, and I'm engineering undecided.
I'm Hannah Sanders, and I'm majoring in environmental engineering.
Both our teams worked collaboratively across two different classes to design a product that addresses the problem of invasive cheatgrass. The GEENgineers worked on a cutting mechanism, while Team Camp worked on a movement mechanism, and we are excited to show you how we tackled this problem and our final product.
First, we have to explain what cheatgrass is. This image right here shows a field of cheatgrass, which is a type of plant. More specifically, it is a non-native weed that has invaded large areas of the western United States. As you can see in the image, it is also very abundant. Cheatgrass is detrimental to its surrounding environment because it creates drastic changes in the composition of the other plants that grow around it. And this leads to increased soil erosion. Cheatgrass also creates a significantly increased danger of wildfires because the cheatgrass allows the fire to carry over large areas and distances. Here are two closer up images of cheatgrass, which allow you to see the plant seeds. Cheatgrass spreads very easily because when the plant turns yellow and dies, it drops its seeds, which causes even more cheatgrass to grow the following season.
With our project, we had a client. Our clients are Christelle and Alex Markovic. A family living west of Boulder have noticed the presence of cheatgrass in their backyard and their community. And after extensively researching into what cheatgrass is and its negative impact on the environment and wildlife, they looked into different methods of removing it. The best way they have done it was by manually cutting and collecting the seeds of the cheatgrass before the seeds fall and harvest for the next year. As you can see, they found this method beneficial from decreasing and removing the presence of cheatgrass. But this method is not ideal. They wanted a product that could be 30 times the efficiency of the hand operation, which is a problem that we wanted to address.
Hey guys, let's go over the CAD design for the cart. So this cart was CAD'd in SolidWorks and rendered in SolidWorks Visualize. We also used PVC connector libraries for the PVC connectors and extruded circles for the PVC pipes themselves. We also used many components and interconnected them together. As you can see, this blue plastic barrel we were originally going to use, but we might use that in future work. Here's another view of the CAD design of the cart.
Here we have a CAD render of our part, the reel. Essentially, the way this part works is we will have a cutter bar right here. The entire part will spin around this axle in a counterclockwise fashion, drawing grass into the cutter bar right here, where it will be cut and deposited behind. As can be seen, we have two hexagonal bases here and here. These bases will be made out of pressure formed plywood. Originally, we did have some concerns about the structural integrity of the plywood. However, ITLL engineers informed us that the strength of the plywood would well fit what we need. Next, we have these 6 redwood spokes. We chose redwood because it is lightweight, durable, and strong. The redwood that we purchased is also rot resistant, which is important considering this product will be primarily used outdoors. Next, we have our bearing. This bearing will be attached directly into this piece of plywood, and the axle will be put through it, essentially allowing the entire piece to spin smoothly around the axle. Next, we have our interface with our chain system using this chain ring right here. Essentially, the chain will fit around the chain ring like this, pulling the chain ring and spinning the entire part. We will attach the chain ring to the part using these spacers. First, we have these redwood spacers right here to draw the chain ring above the bearing. And next, we have these plastic spacers to allow there to be enough space for the chain to move freely around the chain ring.
Manufacturing the cart and its associated parts went relatively smoothly. Through the process of making this cart, we became very familiar with the miter saw and a handheld drill. We used the miter saw to cut the PVC to the desired lengths that we wanted. We used the drill to drill holes in the PVC connectors so that the wheels for our cart and the spinning axle for the blade wheel could go through the PVC connectors. Using the PVC for the structure of our cart was very beneficial. We were able to swap out PVC lengths very easily. This made it possible for us to test and see which lengths were the best for us to use. You can see here on the left that this was our first CAD. Right here in the middle was our first prototype held together by duct tape. We used the duct tape to see how our structure would hold together instead of using glue, so it wasn't permanent. We then made a few changes, and then once we had everything right exactly how we wanted it, we glued it together and ended up with our final product on the right, as you can see here. Along with our PVC being very easy to swap, we also learned a way to change the height easily using 3D printed little discs that we would insert into the PVC connectors to add a little bit of height if they were off a little bit or if we just needed to add some height quickly. This was a very accurate way to do so. The last step of manufacturing our cart, we made 2 pins that if you release them, our handle will be able to fold up so that you can easily store our cart as seen here in the video.
Manufacturing the reel and its associated components went pretty smoothly. It also allowed us to gain good technical skills with tools like table saws, band saws, miter saws, drill presses, and power drills. And this all amounted to creating the picture you see on the right, our initial design for the reel. Once we put our axle and bearings onto the reel, it was able to spin extremely easily around the axle. We then moved on to a section where we had a little bit of difficulty of mounting the chain ring onto the reel. And we had difficulty with this because the chain ring is so thin that the chain ends up being a little bit wider when it's attached to the chain ring. This means that you can't attach the chain ring to a piece of wood, for example, because then the chain wouldn't fit fully onto the teeth. We tried to solve this by first creating little spacers. However, we ran into the same problem where the teeth were being obscured by the wood, so the chain would not fit onto the chain ring. We fixed this by 3D printing little spacers that were small enough to not obscure the teeth while also being large enough to put a decent amount of space between the chain ring and the wood spacers. And you can see those little 3D printed spacers here on the picture to the right. And in addition to the reel and the mounting the chain ring, we also made a cutter bar by drilling 4 holes into this wood saw blade. And this was so that we could easily mount it to whatever we needed to.
In order to integrate our 2 parts, we decided to use a bike chain and chain rings. We decided on these parts because they are easily interchangeable, as well as being very durable and easy to replace or service. Using these 2 parts would also allow us to mess with gear ratios, which we believed was a really important part of this project. We believed that we needed to make the reel spin faster than the wheels, so that even if the wheels were spinning slowly, we would still catch most of the grass and be able to cut it. This would mean that we would need a larger chain ring on the rear axle than we would on the reel. That would allow it to spin faster, and we could adjust this rate by making either chain ring larger or smaller.
For our first test, we met with our client, the Markoviches, and they showed us to a plot of cheatgrass along the foothills trailhead. The biggest takeaway from this initial test, which you can see here, was that the axle attached to the tires provided enough power to spin the combine wheel. We also found that the clearance between the plywood floor and the combine wheel was ideal for grass being cut. This video is from our second test. From this test, we could see that the cheatgrass would be cut by the combine and blade. We also saw, as you can see here, that because of the length of the cart, it was difficult to push the device. Because of this, we cut down on the length to make it more maneuverable. In this video, you can see that our final design was much more maneuverable.
Hey guys, this is what we would like to work on in the future for our cart. First of all, we would like to explore different materials. PVC works great for now, but we want to look into aluminum extrusions because they might be stronger and more reliable. Second of all, we're 3D printing some of the parts right now that go into the wheels, and they undergo a lot of forces. So we're thinking about replacing them with CNC metal parts. Second, we want to make an all-new collection system for the seeds. Ideally, this would be a specifically designed box connected to rails, which are connected to the second set of rails on the cart. This way, you could slide out the box, dispose of the seeds, and then slide the box back in. Third, we want to make a chain ring housing box. Right now, the chain ring is exposed to all the elements, and the grass could get caught in the chain and get tangled. And we don't want that to happen. So we're thinking about designing a housing box to put around the chain ring so that there would be 2 slits for the chain to go in and out of, and then a mounting point for you to take on and off the box.
For our future works on the reel, blade, and chain, we would like to make some small upgrades to improve the overall effectiveness of the harvester. For the reel, we would like to add larger blockers that are more likely to catch the cheatgrass and pull it into the cutter bar. For the blade, we would like to change to a sharper, serrated blade instead of a saw that will hopefully more effectively cut the grass. And for the chain, we would like to add a chain tensioner, which will increase the efficiency of the power transfer from the wheels to the reel. Overall, we are really happy with our progress, and we're excited to continue working on this project in the future.
Throughout this project and semester, we learned the importance of communicating. We communicated with the client to understand their needs because the project is for them and the community trying to remove invasive cheatgrass. We communicated as a team to be aware of what we had to do for the next deadline so that we could complete the project. We also learned how to communicate with another team. As our professor would like to say, we were working in different time zones because we are 2 different teams from different classes. And communicating with how each other's project is coming along so that they can interfere correctly with each other was key. One of the earlier ways we did this was having an interactive spreadsheet to be aware of the major requirements of each other's pieces as we build our own. We also learned problem-solving skills of thinking ahead of how they would interfere and finding new ways to adjust and improve not just our own, but each other's components. We also learned new skills from each other and how to operate new machines.